chemical peels. In order to understand them, we need to talk about the skin a little bit. The bottom layer of your skin is the dermis, and above that you have your epidermis. The epidermis is made of 7 layers. The top layer of your skin is called the stratum corneum. The stratum corneum is made up of the dead cells that are no longer attached to the rest of the living tissue, but are still stuck to your skin. They sit in kind of a bricklay pattern on the outside, and they're what give our skin that aging look. We want our cells to turn over, but they're stuck there in our oils or our sebaceous bilayer. That's what chemical peels are doing. We're going in and dissolving that oil bilayer that's attaching the dead skin cells to us, so that then the cells themselves can fall away. In order to understand chemical peels, we also need to understand the pH scale. I think most of us are fairly familiar with the pH scale. We all learned about it in chemistry class, but as a review, the pH scale goes from acid to alkaline with numbers 0 through 14, 7 being neutral, which is where your water is. So when we're looking at the pH scale, we want to think about how acidic things are. We need to keep in mind that every jump over is actually 10 times the amount. So going from 7 to 6 is actually times 10, not times 1. And from 6 to 5 is 100, etc. So at 7 is our neutral, that's where you'll find your water. When we go out to our alkaline side, we've got our bleach and baking soda. If we're going more acidic, we have urine, we have coffee, we have orange juice, we have our gastric acid, which is what's in our stomach that breaks down food. Our skin naturally sits around 4.5 to 5.5 on the pH scale. It depends on the person, everybody's going to have a little bit of variation, but that range of 4.5 to 5.5 is fairly accurate for most people. So when we're talking about the pH of chemical peels, we are going more acidic than your skin naturally sits. Chemical peels vary quite a bit. The lowest one I have on hand has a pH of 0.8, which is significantly more acidic than your skin. What we're doing is we're raising the acidity level so that the oils dissolve, and then using a neutralizer on top of the peel to bring back your skin's natural acidity. We still want it to stay acid at that 4.5 to 5.5, but we do want to return it to normal. How acidic affects then the depth of the peel. We have 3 categories that we use for peels: our surface depth peels, our medium depth peels, and our deep depth peels. Deep peels hit the dermis, medium depth peels do not, and surface peels are only going to affect the stratum corneum. With chemical peels, it's not necessarily the deepest peel that you want. It depends on what you're trying to target. There's more to it than just the pH for how deep it's going to go, though. We want to think about the molecular weight. The smaller the molecular size of the acid that we're picking, the easier time it will have getting down. When you're looking at how deep you want to go with the peel, we're thinking about what we're targeting. So things like your lines and wrinkles, your pigmentation, are much further down in your skin, whereas acne or just dullness of the skin sits right at the top. So a surface level peel is good for dry skin or acne, where a medium depth peel is good for pigmentation, and a deep depth peel is good for your lines and wrinkles. The more we peel and shed that skin, the more our skin produces new cells to come up and reach the top. And that is what chemical peels do.